Got a 1997 Acura RL. Uncle said, hey, battery light's on. He bought an alternator. Simply put, we're gonna have to put an alternator on here. But I'm just curious. I've had some vehicles that had bad alternators not be bad, so it'd be like a false positive. I think I said it right. It's a false negative. So despite it saying that it needs one, the alternator will be fine. But in rare cases, you'll have issues with the L terminal. Because the battery light's on, the alternator can still charge depending on what failed internally with the alternator. The battery light's on in this car, the brake light's on in this car. It still starts up fine, I'm gonna show you that. So best odds are just throw an alternator on it and call it a day. I will say, just for the sake of history, I have put valve covers on here recently, and what will happen in some instances, if you see all that oil remnants on top of the alternator, the valve covers will leak. Oil will get collect on the alternator. It'll damage the connections, and it'll cause the alternator to prematurely fail. Oil and electronics are not going to go together. It'll just crud it up. It'll just make a mess. It doesn't need to be there. So we got a battery light, brake light, failed alternator. It could be the L terminal, like I was saying, but still replace the alternator. So what I'm gonna do, I'm just gonna do some old school tests. I'm gonna check the voltage. I do have an amp clamp. I could check the amps from the alternator, but I don't have a good means of getting around that battery cable down there that goes straight to the alternator. So more than likely, I'll just check the voltage, see what it states, see the battery light on, check the voltage, and just replace it. So the voltage can be fine. Disconnecting the battery the old school way can still keep the vehicle running. But again, just because the light's on for the battery and it starts up and run fine, doesn't necessarily mean the alternator's bad, but it's something within the alternator typically that's not sending 12 volts back to that L terminal. That's causing the alternator to detect that is defective, and that's why I said a false positive. I think I said it right. I keep throwing myself off because false positive, even though it's the inverse, will throw me off a little bit. It's a false positive. All right, I can't remember where I left off. All right, let's go into the car, see what the battery light, if it's still active, and then come back out and check the voltage value. And we'll go from there. So again, the battery light's on, starts up great. Here's our battery indicator right there, check engine light. I don't know why that's on, but the brake light here, I can't tell you how many miles is on this thing because it's not working. We'll find out if it's the original alternator when I pull it off. Now I do need to go to the parts store and get some 10mm sockets because the 3/8 10mm I have like developed feet and walked off. It'll be like that. So I have my test meter, it's fluke here on voltage, direct voltage. There's the alternator, we're testing direct voltage. Here we go, negative to negative, positive to positive. This should be in less than 14 volts. And it's making 12.4. The headlights are on. Let me turn the loads off, see what happens. All right, it went up a little bit. Let me rev the engine and see if it goes up a little bit. Can't get down there. One other thing I could do, I could take a little bar and hit on the alternator. It might start working again. Ideally, you want to hit the back of it because it's a possibility that since all the electrical components are in the back, I can't get to it though. this is pretty tight. I would have to pull all this stuff off, but if I pull it off, I'm gonna have to repair it. So now let's do the old school way. Pull off a battery terminal. I'm gonna pull off the positive and see if it shuts down. Now logically you don't want to pull off the positive first because it's still active, because if you ground this out it's going to spark. But I guess being aware, you can better manage, but mistakes still happen. Now logically this should shut down because the alternator is only producing 12.5 volts, 12.3. But now I don't know if this just from the battery, which it should be from the battery because the light came on last night and then here it is today. So it's still lightly running off the reserve capacity of the battery. The reserve capacity can be found on the battery. It's RC, that's what it'll be abbreviated as. Now if it has like a RC of 90, then you have 90 minutes on a perfectly charged battery with all the accessories off to get to your destination. 90 minutes is an hour and a half. Typically they're over 60, but less than 90, I would assume. So that'll give you the ability to get where you gotta get within an hour. Now that's just in a perfect world, in a vacuum. Logically though, 40 minutes of driving, logically less than that, because a lot of times people typically realize it and it's too late. So let's see if it shuts down. Oh, and it sure did. All right, you just simply just need an alternator in most cases. Now this is not like a stringent diagnosis. This is nothing in depth. This is just some old basic tests. We just tested the superficial aspect of it, the voltage level, the output of the alternator, and just the old school way of pulling it, see if the load of the vehicle can be supported by the alternator. Now ideally we will want to check the fuse for the alternator, make sure that's not blown. Check our terminal, make sure it's not corroded. For the wire going to the alternator, check the alternator itself, make sure that wire is not corroded or have any type of poor connection. The connector for the alternator, we ideally should check the appropriate pins to make sure it has the appropriate voltage values. Typically if it has 3 wires, you're going to have voltage on all 3. Hot went on from ignition source, L terminal, and a constant 12 volts. So 1 bias, 2 primarily load capable 12 volt sources. Now this is the old vehicle. It didn't have anything special. Usually that's what's going to be the case. If you pull that plug, you'll have, and you cut the ignition switch on, all should have 12 volts displayed on the multimeter. I might be able to show that to you once I get all this stuff off. And again, it's just so tight, tucked back in there. It's just, in most cases, worth throwing an alternator on it when you have a battery light on, because 98% of the time it works. And I'm gonna be honest, that's what I'm gonna do. But what I'm gonna do differently, when I pull this off, I'll just cut the ignition switch on. I have to put a battery source to it, cut the ignition switch on, and then check those voltages. Hopefully I can give you a little bit more information on that. So let me let this cool down. I'm gonna run to the parts store, go grab a new 10 millimeter or 2 of them, keep those on hand. I might have something I can work with in the meantime, but I'll figure it out shortly. All right, I got a 10 millimeter, I got 3/8 to 1/4 inch, and I got a 12 here. So I didn't go to the parts store. I'm gonna work on getting this battery out, battery tray, and we'll gain access to the battery base. Get that out so we can get some more space. Labor time on this is supposed to be 1.2 hours. That's by the book. Recording lightly, I'll be able to do this in that time. Recording slows me down a little bit versus just going straight through. Got the battery tray. Take out the I don't know if they call it battery seat or whatever, but there was one tray, and we'll take out the lower tray here. These are like 10 millimeters. So this is air duct for the cold air. 1, 2, 3, 4. So I took out the reservoir, took out the vacuum box, vacuum reservoir, we're going to call it, for the power steering. I said, God, did I say power steering? This is the, I haven't seen these in so long, cruise control. It's mechanical, it's electronically controlled cruise control model. I haven't seen those in so long. And this right here just pretty much stores vacuum for when you decide to add or take away. So it'll have a vacuum supply ready just in case you're accelerating and you're not in vacuum mode. This stores vacuum. I should be able to pull this out, and you'll be able to hear like, psst. See, it depleted, so it stores vacuum. That's all I do. All right, moving on. We have a lot more space for the alternator. See if I can move this camera around. I got the battery tray, everything removed. I did hit it with some brake cleaner just so I can get it a little bit cleaned up. I'm gonna replace this belt also. It looks horrible. The alternator belt is right there in the front. See the harmonic balancer at the top here? There's the harmonic balancer right there. Here's the belt. I want to flip it around and show you how bad it is, but when I get it all the way off, then you'll be able to see it a lot better. It's ate up real bad, really bad. So if you was to have to diagnose this, you can go in the back, get like a jump box, hook it up to the negative and the positive, and you can pull the connector out. Here's the connector for the alternator right here in the back, and you'll be able to check the voltage supply. This is likely going to be an original alternator, so I'm pulling this joker off. I'm not going to question it. So what do we got here? We got the tensioner. The alternator itself is the tensioner for the alternator belt itself. So it looks like a 12 millimeter. Oh gosh. So we got that. Oh man, I don't know. I think this tensioner is just broke. It's not supposed to look like this. There should be like a bolt head or something on here to tighten up, to draw this bolt up. Maybe. Yeah, this is broken. Yeah, this is not supposed to look like this. Yeah, this one's broken. It's no big deal, because what I could do is take a pry bar, pry it up against here, the bracket for the alternator, and tighten the belt up. No big deal. It's broke and it's not going to stop me. I'm going to take this belt off and show you how bad it is. Look at that. Oh man, this is not a design. This is just a really bad belt. Look at that. It don't get no worse than that besides broken. And yeah, you can only imagine how the other belts probably look. At some point in time of this car's life, we're going to do the time belt and water pump, and then we can worry about the rest later. Yeah, all the other belts are going to be bad. Also, the compressor belt too. I can feel the groove missing inside of there. So you can see why I'm just throwing the alternator on here. It's got to be bad. All right, we got the other bolt down here at the bottom. Would feel like a 12 also. And I'm wrong. It's gonna be a 14. Yep, there it goes. Let's get a ratchet. My Afro-American instinct is feeling a little lazy. I really should get my driver, but I think that's probably a bad decision because I already got the bolt out. And let's see if it'll out. Let me see if I can move it out as it is. See what happens. Said an hour and a half for a reason, but I think I might get lucky and find a way. No, I'm gonna have to pull that bracket off. No big deal. Let's see what I need. I'm gonna pull this ground strap over there. So there's one bolt here, one here, and there's some down at the bottom. I'll remove this one first. And I think I can see what needs to happen from there. I think I'm about to strip the damn thing. I think I about stripped it. Let me see here. Yeah, I did it. I didn't have a good seat on it. Oh, God. All right. Impact guns aren't the greatest, but that was my fault. So let me see. Nope, didn't make any difference in getting that off. I imagine it could be twisted a particular way. Oh wow, no. Wow, it just came out. Ask me how to get it back in. I don't know what the hell it did. Oh, so we're not taking that bracket off. Score one for the blacks. I'm gonna try to do it the same way. Let's pull this connector out. Well, there's a will, there's a way. All right, so we got that out. This is going to be a 4-pin connector. And what I could do, and again, it's 4 pins. Typically, you'll have one bias voltage. So meaning if I put a test light to it, 3 will have a load and illuminate the light. This one here is going to be bias voltage and will not illuminate, but it'll display on the multimeter. Let's see if that's true. If there's one missing, check for the appropriate circuit. I'm not gonna go crazy in depth because a lot of people don't like in-depth videos. This is not that serious. So let's get the multimeter out. We're gonna put it on direct voltage. And I need a power source, so I'm gonna put a jump box to the negative and the positive. I can jump the tower of the shock tower here. Put my ground there, and I don't have to let it interfere with anything else. Key on. Make sure my battery positive for the alternator isn't hitting any grounds. Let me turn the key on. All right, all the lights came on. Need to find a good ground. What better place than the actual ground here? Let me get an alligator clamp. Don't get confused, it's the first thing I get my hands on. Despite it being red as ground. There we go. Test our multimeter. This should go to 12 volts. It doesn't. Make sure the grounds are appropriate. Make sure you have a good connection. Sometimes I like may have pressed the button up top. So we got 11 volts. Now, let me go down so we can zoom in. Hold on. That's too close. That's just right. So what we need to do, check those pins at the connector. We should have 12 volts. Nope, that's not 12 volts. That's probably our control wire. So it's probably computer controlled. That's 11. The remaining 3 should be 12 volts then. So this is our probably the C terminal control, or I don't know if they probably would consider the field terminal. So that's making 5 volts there. Typically, what I've seen, if it is making 5 volts, then that's probably what sends the ground signal or determine how the alternator's duty cycle should be controlled through the PCM. So logically, I'd imagine if I go to the PCM, that's going to be our probably the F terminal and the 5 volt wire here. So those top, this wire, this wire, this wire supplies 12 volts. One of them should not have actual voltage and would be the bias voltage. Let me get my test light. Go. Right, here we go. We got a test light here. It's a 1 ohm test light. It's about, the last time I tested this is support, not a 1 amp, but it was about 200 milliamps load. All right. Illumination, and that's dull, that's dim. So this is going to be our L terminal right here. That's going to be our L terminal. And what I could do to test that L terminal is put my alligator clamp on the battery positive and backfeed that. The light in the car should go out if I did this appropriately. Yep, the battery light is in fact out. Let me take it off. It should, if I ground this, it should come on. There it go. It's down at the bottom. So it is on. Let me take it off. It should go back out. Yep, it's out. So the L terminal is working fine. And like I say, the L terminal is a, what do they call that thing? It's an ISO potential, so it sends it can sustain voltage going either way. So it's like this test light here. That L terminal is like the test light. If I put this, just follow me here. If I'm the L terminal inside that car, this is the light that you see, the battery light. When it illuminates, it's active. So anytime the alternator shorts out and go bad, the light illuminates. When you start it up, there should be 12 volts going through it, and the battery light should be off. So that's why you see the battery light typically on when the car is, the key is in the on position, car's off typically. But when you disconnect it, it goes off. Okay, it's just how the circuit's designed. I hope that's being descriptive enough. I don't want to confuse anybody. I hope I didn't confuse myself neither. So let's pull the rest of this alternator out and get this joker replaced. There's a lot of other ways to test this alternator. I mean, you can go as in depth as you want, checking the raw data, the field terminal, and you know, the output with the amps, the battery wire in the back. You know, is that hooked up properly? You know, do I have 12 volts going through that? And I can check that real quick. You might not be able to see the battery wire, but that wire is the one with the thick nut. That don't sound right. The insulation over it. So I'm going to look for just some illumination, which will indicate that we do have some sort of continuity. And I'm just right at the nut. So that indicates that there's power coming from here down to the battery wire, which implies that we have a good connection. So like I said, there's a lot more ways we could diagnose this, like go further. But let's continue. Let's take this off first before I screw something up. So we have no power going to. We gotta get that nut off right there. And I think that's gonna be a 12. So the premise of a test light is just to load test it. You're not going to get a direct value of it. Just like we had 12 volts from the L terminal, but the light wasn't illuminating heavy, so it was bringing low amperage. So it's probably, if that was if the test light was heavily lit at let's just say, because that light is like 400, I want to say 400 milliamp light, it'll illuminate really bright. That had to been putting out at least 200 or less milliamps. Make it out there. Put this around. Get this baby out of there. Wiring is confusing. There we go. Despite what they say on the internet, you ain't gotta listen. Oh, let me show you. This is a factory alternator. This is Honda, that green. Yep, look at that Honda right there. Oh yeah. And it's saturated in oil, like I was saying. Remember, I had changed the valve covers on here. All right, guys. So what I'm gonna do, I'm gonna go ahead and get this in reverse order. You've seen what needs to happen. and now it's time to be what needs to happen. So I'm gonna do my part, get this in reverse order. We'll test the voltage and call it a day. I got the alternator down there. I kind of slid it in there, and I'm like, okay, I need to show the people how I slid it back in there, because I understand how it is on the internet. You know, you want a better visual representation of what's going on. I don't blame you. So we're gonna try to achieve that. I got putting in the battery wire right now. The bolt, the nut that it came with for the tower mount, the stud, this is gonna be a 12 millimeter. That is the bolt size for the aftermarket one, which is the correct one. I'm gonna put the plug back in. Fight it. Here we are. I guess the main thing is to get the belt back on. Gotta overcome that little lip. The main thing is to get the belt back on because the tensioner is screwed up. So I'm gonna get the lower bolt in there first. If I find out where I put it. So we're right on schedule. In regards to the labor time, the biggest savior is not having to pull off that bracket. There you go. Tell you what, let me get my 14 millimeter, put some pressure on that lower bolt, pull that trigger, let it drop itself on. Put some pressure on it, it'll run itself on when it oh shoot, come on, don't do me like that, fall. Okay, good, it fell all the way through. That's not a good idea. Leave my tools on the top of the lid there. Move it. There you go, latch on. All right. We're gonna get the top one. There's our broken adjustment screw. Oh, you know what? Well, regardless, even if I have an adjustment in the back, this is an adjustment here in the back. Regardless if that's there, there's nothing to push up against at the top, so it's still broken, which is fine. I mean, I don't need it. Did I put that right? Yeah, I did. Gotta fall back into place. This backing line. 12 millimeter. I keep putting my tools up there and they're gonna keep falling. I'm insane. I keep doing the same thing expecting a different result, right? That's the definition of insanity. Right now we got a belt. I thought that I needed to buy a belt myself, but he already had one. I don't know if I mentioned that. Belt on. Belt. Pulley is a little different. I don't know which way it turns when I start it up. Turn it. Oh man. I just didn't have to pull all the way up. It kind of got my thumb too. Tighten that up, man. So gonna snug it just a tad bit, and that way it'll hold itself when I go to put the pry bar to it and close off that deflection. Let me get a pry bar. So the plan is to go through here. There you can see it's holding itself. Okay. And you know what? I'm not going to edit that out. I am not going to edit that out. So I did break one of the ears. I'm going to show you that. That's the byproduct, or the consequence of not having the appropriate tensioner. So I put it here. When I go to apply some force, it did break that part of the housing. It's nothing bad. It's just like a little vent, but it shouldn't be broke. I'm gonna try it again without breaking it. Maybe I can get a better grasp on it somewhere else. But I don't see where I could. Uh-oh. Look at that, I'm breaking another one. This is not good. This is not good at all. This is real life mechanic stuff here. I mean, it's kind of tight. I want to get a little tighter. What I could do is just not going to be respected, but I could just take the meat here and tap it with the hammer. I mean, it's kind of tight there, so let me tighten it up, see what happens. But I hindsight is always 20/20. That's all I can tell you. And once I tighten the bottom up, hopefully it should straighten up and tighten itself up even further. You should be fine. I'm gonna show you exactly what I broke off to. I'm not even gonna hide that. Just give me a minute. Let me get this on here. Now it's a possibility the belt may stretch and it'll probably loosen up over time, but I mean at the moment it's very tight, so I'm not going to worry about it. All right, let me show you my screw up here. See that fin right there, the one in the center that's missing, and I did crack the other one neighboring it, but it's not gonna keep it from working. You know, the biggest thing is hopefully it didn't fall inside that stator, and because yeah, we're gonna have some problems. Hopefully that pressure pushed it out. I didn't see anything of if it did or it didn't. I just got to cross my fingers and hope I didn't screw something up. So I'm not going to act like this stuff don't happen. Currently, it's not affecting the performance of it unless it fell inside of there, which I doubt. We'll see. All right, we're gonna find out if I screwed something up or if that chunk went down in the alternator, because this is gonna let me know ASAP, or if it fell out, and it's probably gonna last as long as the aftermarket alternator is gonna last. So let's see what happens. Hey, what do you know? All right, let's check the voltage. Going to the alternator. Before it was making 12.3 or 2 or something like that. Now it should be making 14 volts. Do the same test. 1425. Logically, we should be able to pull off the negative terminal and it should stay running. Let's do the old school test. What do you know? My vacuum lines are hooked up, batteries held down properly. This hose's going to need to be replaced. Look how it's expanded. I put a X on it so he'll know, but I digress. So the alternator, so the car's running fine. Everything's working like it's supposed to. When I tell you went through the most basic test we probably could, just to have some form of deduction, like we're going about this the appropriate way to replace the alternator. We did some superficial tests, testing the battery, the voltage at the battery, putting out 12.2, 12.3 volts. Did the old school method, pulled off the battery terminal. Now, depending on who you ask, logically, it doesn't matter. You can pull off negative or positive. Take your pick. You know, it's subjective. Either way, there's no continuous loop for voltage, and we're still at the end of the day going to determine how the alternator is able to support the load of the engine, pulling either one of the terminals off. Take your risk. The less risk is obviously pulling off the negative. I pull off the positive. It is what it is. Car shut down. Pulled the battery out. Put a jumper box to it, and key on engine off. Check the output values at the connector. Without looking at wiring diagrams, for anybody in the future, those are good values, because in hindsight, we didn't know, but we know that's a working value. We had 12 volts on 3 pins, 5 volts on another, which I think was the control terminal. And we did a load test at the battery positive wire. So it was like 80% sure, without pulling wire diagrams, hey, we need to put this alternator on here. even the condition of it, which jumps up to like 90% confirmation. Look at the oil was saturated inside the alternator. Again, oil shouldn't go anywhere but inside the engine to hydro lubricate those components. It was on an alternator. Electricity doesn't need any oil. It'll gum up components, cause inefficiencies, cause arcing or bridging of the voltage, because it is a conductor. The fluid is. It can also gum up the brushes, cause things to prematurely fail. Those brushes don't need to be lubricated. Who knows what could happen? Who knows what failed on that alternator? Could have just been age. That is the original alternator. And I'll say this: if anybody have any questions about how to diagnose this is for the average person. We have a standard of what needs to happen without anyone else having to look up a wire diagram. You saw the pins, you kind of got the face of the connector, so you got an idea of what to check. I get a lot of questions. I'm not going to help anybody who doesn't put forth effort into diagnosing things themselves. The video should encapsulate a lot of what should happen on the person who's tackling this on their end. If a person's not taking the initiative to help me help them by providing me with adequate information, I'm not going to answer it. It's like, come on, man. So we check the L terminal. Hopefully the person can grasp the concept of that. That needs is from one end to another, 12 volts getting supplied like I did with the test light. If that connection, if the alternator grounds out that test light, is shorting it, causing that light to illuminate, thus causing the battery light to illuminate. That's why we get an indication that the alternator is defective. Now, I want to say there has been cases where I've diagnosed vehicles before and recorded it, documented it, where the L terminal is defective, but the alternator works. I think it was a Nissan Maxima I did and a Ford truck, I want to say. Don't hold me on that, but I've had that happen. Majority of the time, when an alternator battery light comes on, then it's an indication that the alternator is defective, and it's just best just to throw another one in there anyway. They're going through a lot of stress. Usually the culprit, throw another one in there. Now, also, I have had bad new parts from AutoZone. The alternator that I just put in, my uncle bought, came from AutoZone. Remember the Toyota, the 4Runner, put a bad brand new alternator in there. Had that documented. Y'all saw that. I went through the diagnostic procedure, checked the connector. I knew for 100% that alternator should have been working. Didn't work right out the box. So I had a missed phone call. Well, I had a phone call coming in. So that 4Runner, we knew unequivocally that joker was defective. So I didn't have any issues putting another or questioning that alternator I just put in, because I knew the circuit should have worked. Pulled it out, put another one in there. I think we got the other one from O'Reilly's. Worked just fine. Now, don't get me wrong. I've had O'Reilly's parts of the Ultima starters right out the box do the same thing. Months later do the same thing. I mean, but then again, I replace a lot more alternators than, you know, I would say, honestly, it's like a 60% chance they not gonna work. I hate to say it, but I mean, these aftermarket parts are so iffy. I've had documentation of videos where, like the Chevy, I worked on standard products, right out the box, didn't work. Mass airflow sensor from O'Reilly's, the Blue Streak, right out the box, didn't work. And it's not them per se, but I do spend a lot more money there than I do AutoZone. And I have to go to get a factory quality part, from the mass airflow sensor to the Mazda. I had to go get a Denso, and the standard product from O'Reilly's, I had to go. Luckily, AutoZone had the factory GM part, so it happens. But if roll the dice, pick your evil. You know, no, I can understand why people go to the dealership to get parts, but I digress. Alternator's gonna fail. That's my point. I'm trying to convey. I've heard other sides also, so I don't want to talk more on harp on this. Go on about this, but anyway, but again, if the person has any questions in regards to what to do as far as tests, I'll try my best to answer it. But again, help me help you and put forth some effort. I'm human just like everybody else. Give me a give me a long list. I don't care how long you write it, what you've done, what you've checked. Treat it like a case study. Let me put forth my 2 cents. Maybe we can go a little further. My success with helping other people is when they know how to help themselves and when they get stuck, and we can put our heads together. So anyway, I'm moving on. If anything happens, I'll definitely update. But hit that link, subscribe to the channel, stay informed, had it rich with my work. See you on the next one. And I know this is broke. Don't say anything. I know it. I know somebody probably gonna be like, hey, you know your intake hose. It's broke. See you on the next one. Here's our voltage regulator. Here's our stator. Then we have the armature brushes. I'm gonna pull the rest of that out. That's a stator. I think I can get the regulator out of there. Voltage regulator. This is where the brushes go. You can see where oil got in there, and the dust from the brushes got clogged in the housing here instead of just formulating dust and blowing away. But it just accumulated. Here's the commutator. There's the problem right there. So we probably could have just threw like some brushes on it and been fine. But it could have just been a stress point. Here on the commutator. And probably just wear out. See how one side's supposed to look. See how the other side's supposed to look. This is where the brushes come in contact. But you can see the oil dripping down in there. Let me give you more closer up look at what happened when the oil gets in there. There's the cover, oil got saturated in there. So basically this alternator failed because it wasn't making contact. Look at that top brush there. Put the context clues and make an assumption based off of what you're seeing, but that's why the alternator failed. The voltage regulator light was fine. See the commutator here. Look at that groove it wore. And what can happen, I don't know if you ever mess with RC cars or not, but if you ever put WD-40 inside of an electric motor, it really stresses that contact out and it makes it work harder. So if you put 12 volts to electric motor, spray WD-40 in there, and the RPM increases. I guess because it lubricates it and bridges that contact, but doesn't short it out. So so even if you was to apply more pressure to the brushes at the commutator of a rotating motor, it'll make it faster. So more pressure will cause that. So what happens, this logically just failed because of the oil getting in there, contaminating it. So it made it work harder essentially. And we see the results of that. All right, let me put this stuff back. I'm going.